Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11 and class 12 topics. Okay, if you wish to go through the previous video of liquid solution, you should find link given in the description as well as right up here. Now we were discussing about ideal and non-ideal solution in the previous video of liquid solution. Okay, today we will be discussing about solubility. Now let me tell you one thing about solubility, that this segment of this chapter is not that important as compared to other segments. Rarely questions are asked, but let me tell you, if they ask any question from this segment, consider yourself lucky. Why? Because questions from this segment are going to be very easy and you will feel no difficulty if you solve the question, if you have already solved the question of colligative property and Raoult's law. Those are already easy and this is easier. Okay, so let's understand the meaning of solubility. Solubility means the maximum amount of solute that you can dissolve in unit amount of solvent, at a particular temperature in order to make it saturated. Means you take unit amount of solvent. Now this unit amount can be anything. Like it could be unit gram, it could be unit kilogram, it could be unit liter, it could be unit ml, doesn't matter. So you add here solvent. You add here some solute up to make it saturated. Okay, you keep adding solute, keep adding solute, keep adding solute. So after some time, you will find that you are not able to dissolve any further solute. We say if we have achieved the saturation, and this phenomena, the maximum amount that we have already dissolved in this solvent will be called solubility. Okay, means maximum amount जो कि आप किसी unit amount of solvent में dissolve कर सकते हो solute के, उस amount को हम लोग उस temperature पे solubility नाम देते हैं. Unit क्या होगी? What will be the unit of solubility? Solubility will be something per gram of solvent or per liter of solvent or per kg of solvent, like that. So I here wrote two unit, gram per liter, mole per liter, or if you wish I can write gram per kg also. Gram of solute dissolved in per kg of solvent, like that. Okay, I hope definition of solubility is clear to us. Okay, let's see some more points about solubility. Okay, now see the factors affecting solubility of solid solute in liquid solvent. Solid solute and liquid solvent. So the first factor is nature of solute. There is a saying in chemistry, like dissolves like. Means if I am polar, so I will dissolve polar substances. If I am polar solvent, so I will dissolve polar substances. At the very same time, if I am non-polar, so I will like to dissolve non-polar substances. Clear? For example, if you have NaCl, you dissolve that in water, so it will be easily dissolved. Why? Because water is polar in nature. Water has poles, delta plus delta minus. Similarly, NaCl also has poles, Na plus and Cl minus. So NaCl will be dissolved in water easily. Okay. At the very same time, if you try to dissolve NaCl in benzene, so it will not be dissolved. It will simply, if you add some amount of salt in your benzene, so it will be simply deposited. It will not be dissolved. Why? Because benzene is not polar and NaCl is what? Polar. Good. Now, at the very same time, if you add naphthalene in benzene, it will be easily dissolved. Why? Because naphthalene, you know naphthalene, white color balls, that can, I hope it will be present in your home also. So naphthalene, if you dissolve in benzene, easily dissolved. Why? Non-polar, non-polar. But if you try to dissolve naphthalene in water, it will be undissolved or it will not be dissolved. Okay, is this clear to us? Good. Now, if you try, suppose if you have some mud, if you try to dissolve in water, will mud will be dissolved? No. But if you have sugar with you, you try to dissolve in water, will it be dissolved? Yes. If you wish to perform an experiment, you can perform. You can easily take one glass of water and try to add some sand in it. See whether it will be dissolved or not. Okay. Now, second factor is pressure. I hope you know that solids are incompressible in nature. Means they are not that much compressed. So if they are not that much compressed, so pressure, external pressure, has no particular or significant effect on solubility of solids. So say I have written no significant effect. Why? Because solids are incompressible. So if you can't compress solid, so how will their solubility will be affected? Now, third effect is temperature. Now, if you have solute and if you add it in solvent, so you get solution. See, solid solute, liquid solvent, reversible solution, you are getting liquid. Is this clear? Now, after some time, what will happen if you keep dissolving solute in solvent? If you wish, you can perform an experiment also. You take a glass of water, add some amount of salt, and you could keep adding. You keep adding. You will find when you dissolve one spoon of salt, it was dissolved in water. When you added 2 spoons of salt, it was again dissolved. When you added 3 spoons of salt, maybe dissolved. But if you will keep adding salt like 10 or 15 spoons, you will find that no further NaCl is being dissolved in water. So we say an equilibrium is achieved or a saturation is achieved. At that time, some solute particle interact with water to get dissolved in it. At the very same time, some dissolved particle also interact with solid particle to become solute. Means you will achieve an equilibrium like this. Okay. So for this equilibrium, if delta H is positive, means exothermic. So remember, I hope you remember this, कि Lee-Chatelier principle says for endothermic process, if we increase the temperature, so tell me, solubility will increase, equilibrium will shift in forward direction, equilibrium will shift in backward direction. What we will say? We will say equilibrium will shift in forward direction. Why? Because endothermic reaction favors high temperature. So if temperature is high, so you will find equilibrium shift in forward. Forward means what? Towards solution or towards solute plus solvent. Means more solution will be formed or more solute plus solvent will be formed. More solvent will be formed, solution will be formed. That means more amount of solute will be dissolved. So you will find more solubility. Solubility is increasing. Are you getting this? At the very same time, if you decrease the temp, or if you have exothermic process, let's say this is exothermic reaction, and you keep increasing the temperature. So I hope you know, if for exothermic reaction, if you increase the temperature, equilibrium shifts backward. Backward means if you are having a solution, you will feel like the solute is being segregated. Solute is being segregated means it is getting separated from your solution. So means reaction is coming backward. Solute will become now less soluble and your solubility will decrease. I hope these factors are clear to you. Okay. Now let me tell you one very important thing, that no question will be asked from this section. I'm telling you, no question will be asked. They never ask question from solubility of solid in liquid. They generally ask solubility of liquid in liquid, or they ask solubility of gas in liquid. So this portion is not that important. Are you getting this? Okay, let's move to the next factor. Now if question will be asked, so question will be asked from this segment only. What is that? Factors affecting solubility of gas in liquid. Means solvent is what? Liquid. What we are doing? We are dissolving gas in a liquid. So let's see the first factor. First factor is nature of gas. Now before writing anything in nature of gas, let me ask you one easy question. Who will be more dissolved in water? Who will be more dissolved in water? Whether your ammonia will be more dissolved in water, or your O2 will be more dissolved in water. Can you answer this? Yes, ammonia will be more dissolved in water. Why? Because when you dissolve ammonia in water, it makes hydrogen bond with water molecule. I hope you remember this. The ammonia, delta minus on nitrogen, delta plus on hydrogen, it interacts with poles of water, and water simply dissolves ammonia in a significant amount. Okay. Now, so NH3 and O2 if I talk about, so I will say NH3 will be more dissolved in water as compared to O2. What I have written here? I have written solubility in water. Now, if I compare, let's say CO2 with O2, can you tell me now who will be more soluble? I hope by your prior knowledge you know that CO2 is more dissolved. In water, oxygen is dissolved in very less amount. We call it dissolved oxygen. CO2 can be dissolved quite significantly. I hope you know that aerated drink that we take, cold drinks like, so CO2 is completely dissolved in that. Okay. So let me tell you, if I say here TC, remember TC? TC is what? Critical temperature. So let's say critical temperature for ammonia is TC1. Critical temperature for CO2 is TC2, and critical temperature for O2 is Tc3. Can you tell me who will have more Tc? If you forgot about Tc, let me remind you, Tc is equals to 8A by 27 Rb. Means Tc is directly proportional to A. What is A? Is van der Waals gas constant, and A measures the force of attraction between particles of gas. It means अगर मैं एक पार्टिकल हूं तो मैं अपने आप को जितनी अच्छे से इंटरेक्ट करूंगा तो मेरे लिए A की वैल्यू उतनी ज्यादा होगी. Regarding this, A is measurement of force of attraction between particles of any gas or any substance. Okay. Now, so can you tell me who will attract more to its particle? Who will attract more to its particle? Whether ammonia will attract more to its own particle or CO2 or O2. So I hope you can understand that ammonia molecule has tendency to form hydrogen bonds. You know, ammonia is like this, huh? So ammonia has tendency to form hydrogen bond. So means ammonia molecules are tightly bound to each other by hydrogen bonding. Okay, CO2 doesn't form hydrogen bond, O2 doesn't form hydrogen bond, but CO2 has higher mass. CO2 has higher mass, and now due to this higher mass, it has capability to attract another CO2 molecule effectively. Are you getting this? Which kind of force it is? Van der Waals force of attraction, and it is directly proportional to mass. So firstly, NH3 attracts more to its own particle, then CO2, and then O2. So who will have more Tc? Tc1 means ammonia will have more Tc as compared to Tc of CO2 and as compared to Tc of oxygen. Are you getting this? So what I am going to conclude, can you think? Can you think about this? What I am going to conclude? I am going to conclude if your Tc is high, so your solubility in water will be high. Are you getting this? So let me write it here. Its solubility is directly proportional to Tc of gas. But solubility in water I should write, because I hope again you understand that solvent will matter. Which type of solvent we are taking. So if nothing is provided, so we take universal solvent, that is water. So solubility in water is directly proportional to Tc of gas. Okay. Now what if I ask you, tell me, SO3 will be more dissolved in water or CO2? SO3 or CO2? Tell me. SO3 or CO2? How will you say? Firstly, you see who has more value of A. Who will have more value of A? Its molar mass is 80, its molar mass is 44. So 80 molar mass will attract more to its own particle or 44? Of course 80. So for SO2, A is higher. A of SO3, sorry. A of SO3 is greater than A of CO2. Okay. So who will attract more to its own particle? SO3. So who will have more Tc? SO3. So Tc will have more value for SO3. So I will say its solubility of SO3 is greater than CO2. So such type of questions can be asked to you. So you should be prepared for them. Okay. Now what if I ask you this? I have four gases. Let's say O2, CO2, N2 and H2. Can you tell me who will be more? Can you arrange them in order of solubility? Yes, I hope so. How? Max, you have to just check the value of A. If value of A is higher, so we say it will be more soluble. So see, O2 molar mass is what? 32. CO2 molar mass is 44. For N2 molar mass is 28. For H2 molar mass is what? Molar mass is just 2. So who will attract more to its own kind? It will be CO2. So CO2 will attract more to its own kind, then O2, then N2, then H2. How? Because more your mass, more van der Waals force of attraction. So more togetherness of the particles. Are you getting this? So who will be having more solubility in water? It will be CO2, then O2, then N2 and then H2. Are you getting this? So I hope you are understanding this. Or you can think like this now. You see, if I am attracting my surrounding particles too much, so if I will be going inside water for getting dissolved, so I will say, come with me, come with me. समझ रहे हो ना, कि खुद तो जाएंगे औरों को भी लेकर के जाएंगे। तो अगर आप ये कहानी कर ले जाते हो, अगर ये आप कब कर सकते हो, व्हेन यू आर सोशली टू मच कनेक्टेड। तो मैं जा रहा हूं, अगर मैं डूब रहा हूं पानी में, तो भैया इनको भी लेके ही जाऊंगा। वंस आई एम ड्राउन इन वाटर, मैं अगर एक बार घुस गया पूरी तरह पानी में, सो आई विल बी सॉल्युबल। क्लियर? सेकंड फैक्टर इज टेम्परेचर। नाउ if you dissolve this gas which is solute in solvent which is liquid, so you'll get a solution. Solution will be what? Liquid, solid or gas? It will be liquid. Why? Because your solvent is liquid. That is the definition of solvent. Now, for this type of reaction or this type of equilibrium, you will always find delta H is negative. Why? Because until unless your gas is not interacting with water molecule, as long as your gas is not interacting with water molecule, let me tell you, your gas will not be dissolved in water. Are you getting this? Until unless your gas particles are not interacting with water, means if they are not forming some sort of bond with water, it could be any sort of bond, it could be simply attractive bond, it could be chemical bond, doesn't matter. If they are not forming any sort of connection with water molecule, they will never be dissolved. They will never be dissolved in water or any given solvent. Regarding this, so in order to interact with water molecule, means some sort of interaction is required. Interaction means some sort of bonding is required. That's bonding, whenever it is formed, heat is always released, so delta H will always be negative. Are you getting this? Good. Now let me tell you one more important thing. If you talk about delta S for this reaction, delta is what? Change in entropy. See, this side entropy is very high. Why? Because we have gas molecule. Gas molecules are very random in nature and they cause too much randomness. You're getting this thing. They cause too much entropy. Now here in liquid form, they will be simply dissolved and their randomness will be completely ceased. So you will see here highly randomness, here very low randomness, so delta S will also be negative. Now I hope you understand that delta G is equals to delta H minus T delta S. Delta G equals to delta H minus T delta S. Now think about this. I am saying that this delta S is negative. I am saying delta S is negative. So this term means including minus sign, it will become positive. You getting this? So if you increase the temperature, so it means that you are increasing this positive part. Are you getting this? So delta G, it will tend towards positive. So tell me, if delta G become positive, process will be spontaneous or process will be non-spontaneous? Process will be non-spontaneous. That means solubility, tell me, it will increase or it will decrease? Solubility will decrease. You're getting this thing? So here, if you increase the temperature, solubility is 100% going to decrease. You can understand this by physically also, and it will be very clear to you once I give you the example. Let's say you have gas molecules dissolved in water. Now you start heating here. So tell me, these molecules, gas molecules, liquid molecule, who will have more tendency to escape? Who will have more tendency to escape this solution form? Liquid molecule or gas molecule? Definitely gas molecule. Why? Because gas was already gas. You somehow made it soluble in water or any given solvent. Now kinetic energy of the system will increase. You are increasing the temperature now. So when you increase the temperature, the kinetic energy of the system will increase. So gaseous molecule will have more tendency to escape. More tendency to escape. Are you getting this thing? So when they have more tendency to escape, so I will say that they don't want to stay in solution, they want to go away. Are you getting this? So if you wish to perform an experiment, you can perform this experiment. Now it is summer already. So You can, after lockdown, I will suggest you purchase this Coca-Cola or any cold drink. Okay, so you keep it in cool and drink it. Okay, so you will feel it is giving you some sort of taste. But at the very same time, if you keep that cold drink outside, not it is still sealed, and then you open it and you try to drink, you will feel that now you are not having that good taste. Reason? When you have low temperature, CO2 will be more dissolved, and when you have high temperature, CO2 will be less dissolved. And let me tell you, taste is coming just because of CO2. Are you getting this? So that's why you will feel when more gas is dissolved in low temperature and less gas is dissolved at high temperature. Temperature phenomena is clear to us? Good. Third factor is pressure effect. Now let me tell you, it is the most important effect as far as solubility of gas in liquid is concerned. If a question will be asked from solubility of gas in a liquid, 99% chances are there that the question will be asked from this section only. Pressure effect, or you can also say from here we will derive this Henry's law. Now firstly, let me tell you how pressure affects the solubility of gas in a given liquid. Let's say if you have this liquid and you have some gaseous molecules over here. Okay, now you do one thing. You can visualize, if I increase pressure above here, so what will happen? This movable piston will come down. This movable piston will come down. Now once it will come down, so what will happen? Space available for gaseous molecule will increase or decrease? It will decrease. So where will those gas molecule go? Those gas molecule will simply go inside the liquid. Means you are doing what? You are saying to gaseous molecule, okay, go inside the liquid, and they will keep going like that. Now, dhakka maar rahe ho. You are pushing gas molecules downwards. Ki bhaiya jao, go inside this water or go inside this liquid. Means get more dissolved. Are you getting this thing? So solubility of a gas will be directly proportional to the pressure applied. More pressure you will apply, more gas will be dissolved. I hope you know that in cold drinks, CO2 is dissolved at very high pressure. Okay, now let's see. So let me tell you the definition. What the statement is: solubility of gas in a given solution is directly proportional to the partial pressure of gas over liquid surface. Means more partial pressure here for the gas, more solubility of gas you will observe in liquid. Or in other words, this statement is written in NCERT as well. NCERT follows this statement. It says the partial pressure of a gas above liquid surface is directly proportional to the mole fraction of it. Mole fraction of what? Gas present in liquid solution. Means if I follow first statement like this, from here I can write this: is solubility, S is solubility, is directly proportional to P. P is what? Partial pressure of gas. And from this statement I can write this: a mole partial pressure is directly proportional to X. Partial pressure is directly proportional to X. What is X? Or you can write X gas. X gas is what? Mole fraction of gas. Now let's remove this proportionality sign in both the cases. So here you will get S is equals to Kp. Okay, this K is what? Henry's constant. Now here, if I remove proportionality sign, again I will get what? Kx. Now NCERT writes this K as Kh. H stands for Henry. So this is also called Henry's constant. So one question arises. In exam, if Henry constant is given, so which formula I will apply? Will I apply this as equals to Kp, or will I apply P equals to K into mole fraction of gas? So let me tell you, it will depend upon the unit of Kh given. It will depend upon unit of Henry's constant given. 99% chances are there they will ask you from this formula only. But for 1%, if they change the form, if they want to change the formula, they will do just one thing. Can you tell me unit of K from here? Unit of K. Now, what is the unit of K? Will be unit of S divided by unit of P. What is S? S is solubility. Okay, tell me what is the unit of solubility? Solubility will be like mole per liter. gram per liter, like that. So I'm taking a general unit, mole per liter. So unit of K will be unit of S divided by unit of P, means mole per liter. And what is the unit of P? P means pressure. Pressure unit is atm. So this is the unit of this K. And what is the unit of here, KH? Unit of KH is what? What is the unit of X? Nothing. Mole fraction has no unit. What is unit of P? Mole fraction of P unit is atm. So here unit is atm. So if they give you solubility or Henry's constant in mole per liter per atm, so you will apply this formula as equals to Kp. If they give you mole fraction or Henry's law constant unit atm, so you will apply this formula, P equals to Kh into X. Please note everything from here. Question will be asked from here only regarding this thing. Okay. Now P equals to what? Kh into X. From here, I hope you can tell me X is inversely proportional to Kh, means higher the value of Kh, lower will be mole fraction of gas in liquid. Regarding this, so we will say its solubility will be less. Solubility will be less. From this formula we are getting this. Okay. Now tell me, NH3, CO2, O2. Who will have maximum KH? Who will have maximum KH? So how will we solve this? Let's see. Can you tell me who has more solubility? So this is what this if I write this arrow, it means it is decreasing order of solubility of gas. I hope we have discussed this. This is what? Decreasing order of solubility of gas. Now, solubility is inversely proportional to what? KH, means less solubility, more KH. More solubility, less KH. So who will have least KH here? It will be NH3 because its solubility is more. So I hope you understand, since its solubility is inversely proportional to KH, so KH of NH3 will be less than KH for CO2 will be less than KH for O2. Regarding this, very good. It's all right. Now let's move to the next question. If I ask you, you tell me if T increases, so tell me what happens to KH? Will it decrease or will it increase? Think, pause the screen, think for a second and then answer. If I increase the temperature, so KH will increase or decrease? So I hope you remember that solubility is inversely proportional to temperature. For gas, solubility is inversely proportional to temperature. Now, if temperature rises, so solubility will decrease. And when solubility decreases, so KH increases. No, we are not getting this. कि अगर solubility ज़्यादा होगी, KH कम होगा. Temperature बढ़ाने से solubility कम हो जाती है, तो पक्का KH बढ़ जाता होगा, isn't it? So, if temperature increases, so that means KH also increases. So, suppose if somebody asks you, tell me KH for N2 300 Kelvin and KH for N2 at, let's say, 600 Kelvin. So who will have higher value? Who will have higher value? Will be at 300 or 600? You will directly say 600. This is what? Value of KH. So this kind of small logical questions can be asked to you. Okay. Now next thing is application of Henry's law. So first application, it is clear to all of us. We know it already. Ki in cold drinks or in soft drinks or in soda waters, CO2 is packed at very high pressure. Okay, so that if high pressure will be there, more gas will be dissolved. Secondly, scuba divers fill their tanks with helium approximately 11.7%, nitrogen approximately 56.2%, and oxygen around 36.1%. Why? Because they want to avoid bends. Now, what is bend? You see, N2 is not dissolved that much. N2 is not dissolved that much if we talk about normal temperature, means atmospheric pressure. Okay, but when the scuba diver goes deep inside seawater, so pressure increases. So when pressure will increase, so what will happen? Nitrogen will be more dissolved in blood. Regarding this thing, nitrogen will be more dissolved in blood, no problem. If nitrogen is getting dissolved in blood, no problem, there is no issue. But when he will come out, When he will come out, so pressure will decrease. Now at low pressure, N2 will be highly dissolved or N2 will be low dissolved, N2 will be less dissolved. Now what will happen? That N2 which was dissolved in your blood, it will not try to come out. It will now try to come out, and let me tell you, this process is very painful, and this process is called bend. Here bend is causing too much pain to the scuba diver when he's coming out of water. That's why they reduce the amount of nitrogen in oxygen tank by adding some amount of helium. So by adding some amount of helium and increasing amount of O2, so N2 will be dissolved, but not that much. You will have to suffer this painful bends. Are you getting this thing? फिर पानी में ब्लड में डिसॉल्व हो गई N2, जब तुम पानी में नीचे जाओगे कोई बात नहीं, डिसॉल्व हो गई कोई लोड नहीं, बाहर आओगे जब तो N2 तुम्हारी ब्लड सेल्स को फाड़ के निकलेगी. इट विल ट्राई टू कोलैप्स योर ब्लड सेल्स, so it will cause you so much pain. Okay. Now third application, higher altitude, low to I hope you know that at higher altitude we have low pressure. Now there what happens ki if low pressure is there, so oxygen will be less dissolved in what do we say, blood. Oxygen will be less dissolved in blood, so supply to your blood supply to your mind or your brain will having low concentration of oxygen. Are you getting this? Since oxygen will be less dissolved in blood, so you will not be able to fulfill the requirement of your brain. Okay, so what will happen? You will feel anxiety, you will feel restlessness, and you will start feeling like what is going on. You may not be able to think clearly. That condition is called anoxia. Are you getting this? So anoxia is caused by low concentration of oxygen in our blood at higher altitude. Okay, now one more thing, at higher altitude, if you are having an asthma or any respiratory disease, so it is advised to you that you carry oxygen cylinder with you. Why? Same reason, at higher altitude low pressure is there, so oxygen is less dissolved to your blood. Are you getting this? So it is advised that you should carry more oxygen cylinder if possible. Okay, let's move forward. Now let's understand limitation of Henry's law. Please pardon the background noise, as you know that this video is being recorded at my home, so please try to ignore. Okay, now limitation of Henry's law. So first limitation, it is valid for only those gases which are sparingly soluble, means which are very less soluble in solvent. Only for only those gases this law will be valid. Okay, next, gas must not get associated or dissociated in liquid, means it's not like you added gas in your liquid and it gets dissociated or it gets associated. No such thing must happen there. Okay, now one more thing, gas must not form any compound in liquid. It's not like it is started reacting with the solvent molecule. No, it must not form any compound in liquid. Fourth, gas must behave ideally. Gas must behave ideally. And where do we observe when we do observe this ideal behavior? At low pressure and high temperature. Okay, so Henry's law has very small range of applicability, so it's not that applicable to all the conditions. Okay, if somebody asks you, is it applicable to NH3 with water? Will NH3 gas and water combination will be applicable for Henry's law? Will Henry's law will be applied here? Say no. Why? Because firstly they will make compound. NH4OH, and that NH4OH is dissociated. So it means that ammonia in water will never be considered as an example for Henry's law. Okay. Now if somebody asks you, will HCl in water, Henry's law applicable or not? Say no. Here also no. Henry's law will not be applicable here. Why? Because they are very high soluble in water. Similarly, Henry's law will not be applicable to SO3 gas also. Why? Because if you add SO3 in water, what will happen? SO3 in water, what will happen? It will give you H2SO4. Compound formation. Compound formation means no applicability of Henry's law. But let me tell you, the first three conditions are same. Means gas must not be highly soluble, it should be sparingly soluble. If you are getting associated or dissociated, that means you are interacting with water molecule, that means you are going to form some sort of compound, that means you are highly soluble. So if first condition is is fulfilled, so rest two will be automatically fulfilled. Don't worry about that. Okay. And let's then this Henry's law will be applicable. Henry's law will be applicable to N2. It will be applicable to H2, helium. It will be applicable to, let's say, O2, but O2 up to a very small extent. CO2 also, it will not be that applicable, but we will find some question based upon CO2. But for CO2 also, ideally Henry's law will not be applicable. Okay, so these are some examples, you should note them down. Okay, and let's move forward. Let's see a problem. Let me tell you, from this section, very elementary problem is asked in NEET or JEE Main. Okay, so the question is, find the amount of O2 dissolved in 180 gram of water at 300 Kelvin, and they are saying if partial pressure of O2 is 0.1 atm and KH value for O2 is 1000 atm. Okay, now what is the unit of KH given to us? 1000 atm. So which formula we will apply? We will apply P is equals to KH into mole fraction of O2. Okay, now is partial pressure, what is P here? P is partial pressure of gas. Is partial pressure of O2 is given to us? Yes. Remember, it is not total pressure. This is what? Partial pressure. So here partial pressure is what? 0.1. What is KH? 1000. Mole fraction of O2. Now mole fraction of O2 will come as how much? 10 to the power minus 1 divided by 1000 means it is coming as 10 to the power minus 4. This is the mole fraction of O2 coming. Now you tell me one thing, I hope you can understand this very easily. Can you tell me, have they asked us mole fraction of O2? No, they asked amount of O2 dissolved. So amount of O2, how will I write? I will write mole fraction of O2 equals to, I will write moles of O2 divided by moles of O2 plus moles of H2O. Now, I hope you remember, Henry's law is applicable to less soluble gases or highly soluble gases. Henry's law is applicable to less soluble gases. Now, if it is applicable to less soluble gases or sparingly soluble gases, so this approximation you can always take. The moles of solute plus moles of solvent means if we are adding some moles of solute in some moles of solvent, so tell me, will there be so much difference? No. So you can approximately write it as just mole fraction of solvent. You getting this? So here what I'm going to do, I'm simply going to put it in O2 upon. Now will I write in the denominator moles of O2 as well? No, because moles of water will be too high. Why I'm saying this? Because if I'm applying Henry's law, so it means it is valid for sparingly soluble gases. So I will write here simply moles of H2O. What is this? It is given as 10 to the power minus 4. Now, how many moles of water we have? Let's see. Moles of water equals to how much? We have 180 divided by 18, that is 10 moles. So we are getting how much? We are getting 10 to the power minus 4 equals to moles of O2 divided by 10. So from here I am getting moles of O2 is equals to 10 to the power minus 3 moles. We're getting this thing. If they ask us the weight of O2 dissolved, so how much weight of O2 is dissolved? 32 into 10 to the power minus 3 gram of O2. Just multiply this moles by 32. 32 is the molecular mass of O2. Are you getting this thing? This question is clear. So always take this as approximation. Always. Okay, let's move forward. Next question is, find the moles of CO2 dissolved in 1 liter of seawater. Given air contains 1% of CO2 and KH for CO2 is 100 atm. Okay, question is clear. You just have to find moles of CO2 dissolved in 1 liter of seawater, and you are given air contains 1% of CO2. Okay, would you like to give this a try? Yes, you will. Just pause the screen, give it an honest try. Okay, now which formula I will apply? I will apply P is equals to KH into mole fraction of CO2. What is P? P is nothing but partial pressure of CO2. What is P? P is partial pressure of CO2. So can you tell me what will be the value of PCO2? What will be the partial pressure of CO2? Now, I hope you understand what is the total pressure produced by air. what is the total pressure produced by air. So let me tell you here, total air pressure equals to how much? I hope you know the total air pressure is 1 atm. Total air pressure is 1 atm. Out of this 1 atm, you have, in this 1 atm, you have all type of gases. You have N2, you have O2, you have CO2, you have H2, you have every single gas. Are you getting this thing? Whatever is found in this atmosphere, those all gases are applying pressure equals to how much? 1 atm. Out of those, what is the percentage of CO2? Percentage of CO2 is 1%. So, pressure of CO2 will be 1% of 1 atm. You're getting this thing? Since your CO2 is present in just 1% in amount, so its pressure will be how much? Just 1% of 1 atm. So means 1 into 1 upon 100 means 10 to the power minus 2 atm. You're getting this thing? 1 into 1 by 100, that is 10 to the power minus 2 atm. Now let me put it here. 10 to the power minus 2 equals to, please pardon the background noise. Kh is what? 10 to the power 2 multiplied by mole fraction of CO2. So what will be the mole fraction of CO2 I will be getting? 10 to the power minus 4. Now can you solve this further? Yes. Now, did they ask us mole fraction of CO2? No. They asked, will write it as moles of CO2 upon moles of water. Remember, I will write just moles of water. Why? Because moles of water I am writing just because I should write here moles of CO2 as well, but I told you already I am taking an approximation. I will not write here moles of CO2 as well, because CO2 moles will be neglected as compared to moles of water. Now equals to how much? 10 to the power minus 4. Now what will be the value of moles of H2O? Moles of H2O will be how much? Moles of H2O will be how much seawater you have taken? 1 liter. 1 liter means how many ml? How many ml means 1000 ml. Now what is density of water in general? Water density is 1 gram per ml. So what weight of water you have taken in 1 liter? 1000 gram. Okay. Divided by what? 18. So if you solve this, it will come as 55.55. If you solve this, it will come as 55.55. So moles of CO2 upon 55.55 equals to 10 to the power minus 4. So that means moles of CO2 equals to 5.55 into 10 to the power minus 3 moles. These many moles of CO2 are dissolved in 1 liter of seawater. Okay, this question part is clear. If 1 liter of water equals to 300,000 ml, 1 ml has weight 1 gram, so 1000 ml will have 1000 gram weight. Okay, let's move forward. Now, this was the last thing to be discussed in this liquid solution topic. Now, this liquid solution is completely over. Okay, now your task will be solve the DPPs attached in the videos. And in the very same video also I have attached one DPP. Solve those questions. Solve all the in-text question and exercise question given in NCERT or whatever textbook you are following. And if doubt arises, you just ask me in the comment section. Okay. Till then, keep studying. Have a good day.